Hi everyone. In this video, I'm going to go over some of the multiple choice questions from my lecture notes. And this week we're covering Chapter 22, Stars from Adolescence to Old Age. This question is a bit of a throwback from our module on the HR diagram and stellar properties. So the question is asking, 4 main sequence stars with different masses are shown on the HR diagram. Which star will live the longest time on the main sequence? For this question, you need to remember that for stars on the main sequence, those on the upper left are hot, luminous, and high mass. These stars use their fuel quickly and live shorter lives compared to the cool, faint, low mass stars on the lower right, which have longer lives. Therefore, the star that will live the longest on the main sequence is star D. Here's another question that is asking you to relate stellar lifetimes and mass. Consider the following information about the lifetime of 3 main sequence stars, A, B, and C. Star A will be a main sequence star for 45 billion years. Star B will be a main sequence star for 70 million years. Star C will be a main sequence star for 800,000 years. Which star has the greatest mass? Remember, the most massive stars have the shortest lives. Of our choices, star C is on the main sequence for the shortest amount of time, only 800,000 years. Therefore, star C is the correct answer. This question is asking, what is the most massive nuclei that can be fused in the core of a 0.25 solar mass star? Well, 0.25 solar masses definitely qualifies as a low mass star, and low mass stars spend most of their lives on the main sequence fusing hydrogen into helium via the proton-proton chain. Once that hydrogen is mostly used up, the star will begin fusing helium into carbon. And a low mass star like this will never get hot enough to fuse that carbon. Therefore, the most massive nuclei that can be fused in a 0.25 solar mass star is helium. This question may look similar to the first question I asked, but here we're focusing on star clusters and their main sequence turnoff points. So the question is asking, the turnoff points for 4 different clusters are shown on the main sequence of the HR diagram. Which of the clusters is the youngest? Remember, the main sequence turnoff is the spectral type of the hottest main sequence star in a star cluster, and the main sequence turnoff tells us the cluster's age. So let's look for a moment at some examples. I'm showing 4 different star clusters here. The main sequence turnoff point for each is here, 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 and here. Of these, the cluster with the hottest main sequence turnoff is cluster D. Therefore, this is the youngest cluster shown. It's so young that none of these hot main sequence B stars have run out of fuel yet and moved off the main sequence. The coolest main sequence turnoff is in cluster C. This cluster is so old that all of the type O, B, A, F, and G stars have already run out of fuel and left the main sequence. So let's go back to our original question. So we want the turnoff for the youngest cluster. This is going to be the hottest turnoff, which here is option A. Now, if I had asked which turnoff corresponds to the oldest cluster, you should be able to figure that out too. So that's all the questions for this week. I hope this helped. Take care, and I'll talk to you again soon.